Institute of Technology and Science, Cochin is delighted to welcome you all to this distinguished online lecture series designed to mold budding engineers engrossed in building our nation. Muthoot Institute of Technology and Science deems that the shuttered buildings and empty auditoriums caused due to pandemic COVID-19 lockdown cannot avert us from cognitive learning and knowledge application. The seismic switch has been a great feat for the evolving techies to connect with the corporate leaders at national and international level. Dr. Subramani Ramakrishnan, fondly called as Subbu, leads the workforce management function for IBM India Client Innovation Center. He joined IBM in 1997 as a graduate trainee, and since then, in the last 23 years, he has played multiple roles including software development, project management, operations and finance, quality process engineering, workforce management, and has led first-of-a-kind projects for global clients of leading diversified multicultural teams. In his career, he has received many accolades from IBM, including the Best of IBM 100% Club Award and Best People Manager. For his work on learning and development and bridging the industry-academia gaps, he has been awarded with many recognition like Brandon Hall Silver Award and Distinguished Alumnus Award from SVCE. A gold medalist from University of Madras in his engineering, he went to do his PG in Software Enterprise Management from IIM Bangalore, where again he secured rank 1 and was a gold medalist. He also holds Masters in Business Administration, Masters in Psychology, and a PhD in Management Studies. Author of the bestseller Shape It, is a regular speaker in industry academic forums, sits on the board of studies of engineering colleges, universities, and strives to bridge the industry-academia gap.
Hi, I would like to thank Professor Chiku Abraham of Muthoot Institute of Technology and Sciences and the management for giving me this opportunity to share my thoughts. And I think this is a great way to engage with young minds and also our school students who are aspiring to be future engineers in this COVID lockdown. I hope all of you are staying safe, and for the next few minutes, I thought I will share my perspectives on how you can engineer your way to engineering. It's not a play of words, but I mean it. How do you engineer your way to engineering? And I thought I would break this into three areas. The first is, let's understand the history of engineering, how it has all evolved. What is engineering? I'll give you some examples of a day in our life and how engineering is all pervasive. The second, let's talk about what's happening around us, the technology disruptions and the new ways of working, and how engineering education is coping up with this challenge and how it is evolving. And the third part would be what, as budding engineers and aspiring engineers in the school, what should you be doing? What are the traits that will ensure you are a successful engineer? What is engineering? Very simply put, engineering is the process of designing the human-made world. Engineering as a word, it's of recent origin. Maybe the last 400, 500 years we are using this phrase as engineering. But while the word engineering came about 400 years back from the Latin root ingenium, which is to devise, to create. But the concept of engineering or the act of engineering probably remained there all along with us from the time the first human made their appearance. Engineering involves critical skills like problem solving, modeling, and optimization. So let's look at some of the engineering marvels in the history of mankind. I'm sure the first and foremost engineering invention was the wheel. And the invention of wheel unlocked a wealth of other tools, including the chariots, the wheelbarrows, the mills, the gears, and even today's watches which use the gears, the steamboats, the bicycles, and all of it, right? So that was the first invention, and very aptly, one of the engineering colleges in the main atrium, they had a huge bullock cart and a huge replica of the wheel to celebrate this first invention or the first engineering marvel. The next one that comes to my mind is the Roman aqueducts. The Romans constructed these aqueducts throughout their empire to bring water from outside sources into the cities and towns. The aqueduct supplied water to the public baths, the latrines, the fountains, and the private households. The aqueducts, the interesting thing is, they moved water through gravity alone, along a straight overall downward gradient within the conduits of stone, brick, or concrete. The steeper the gradient, the faster the flow. Most of the conduits were buried below the ground and followed the contours of the terrain. The obstructing peaks were circumvented or less often tunneled through. Where there were valleys or lowlands, the conduit was carried on the bridgework, or its contents were fed into a high-pressure lead, ceramic, or stone pipes and siphoned across. And the first aqueduct was built in 312 BC. And by the 3rd century, pretty much most of Rome was supported by the aqueducts, right? Or for that matter, who can forget the catapults, right? One of the early warfare equipment. Catapult physics is basically the use of stored energy to hurl a projectile, the payload, without the use of an explosive. The catapult has proven to be a very effective weapon during the ancient times and capable of inflicting great damage. Remember the flying scenes from the Bahubali 2 movie climax scene? It's all the catapult principle. This showed the understanding the ancients had on the 3 primary energy storage mechanisms of tension, torsion, and gravity. These were some of the examples from the ancient times. Let's move forward. Fast forward 1,500 years. Sometime in the 15th, 16th centuries, the primary profession of engineering, when it formally started happening, it was all restricted to the fortification and the military warfare. And starting mid-19th century, the new processing methods, most notably the steel and petroleum, reshaped transportation, construction, and manufacturing. So scientists, entrepreneurs, inventors flourished in this time. In 1851, Isaac Singer patented the continuous stitch sewing machines. In 1868, Christopher Scholes patents the first practical typewriter. 1876, Alexander Graham Bell patents the telephone. 1884, Louis Waterman patents the first practical fountain pen. So these are all happening in the 1850s to 1900s. Up until Civil War, most of the US engineers were primarily the military academicians. And then probably one of the first engineering colleges, which is also going by the name MIT, Massachusetts Institute of Technology, was started in the 1860s with about 15 students. And it's with immense pride we should note that we had in India one of our first engineering schools starting in College of Engineering, Guindy in 1794. What started as a survey school today is the apex body of more than 500 engineering institutions in the state of Tamil Nadu. Moving to the 20th century, engineering literally electrified the country. It electrified the nation. It took us to the sky and the moon and the outer space. It gave us the cars and the highways for us to ride on. It made our waters cleaner and safer. And it revolutionized the way we produced food. Engineering made our homes more comfortable. But the interesting thing is to note that the pace of engineering, the technological change is accelerating today at an unprecedented speed. And it could create a world that we can barely begin to imagine. And most of this crowd of budding aspirants and the budding engineers are as old as Google, right? It's only about 20-25 years. And look at the pace of, and as you can see from this graph, the pace of technological change is exponential. Now, if you don't believe all this, let me get closer home. Let's look at a day in our life. And this is a Chronodex representation of what happens in a day in our life. So you get up, today you have electric toothbrush. And then probably you go for your personal grooming in a salon. Look at the things around you in the salon. There are recommendations engines today to choose the cosmetics based on your skin. There is a company that offers Magic Mirror, where you can select the cosmetic item from the tray, and then the computer vision technology there, it senses this motion of you picking up a specific cosmetic, a specific color lipstick, for example. It triggers the sensors, and the computer vision technology literally applies that color virtually on the lips of the customer. And then you can pick and choose whether it suits your look. Or for that matter, look at the straightening that probably some of you may do for your hair. So our hair strands are built of the keratin, right? The protein called keratin, which is made up of chains of amino acids, right? And keratin is incredibly strong. It's so strong that it makes it hard to break without the use of scissors. So there are some incredibly strong bonds that the keratin builds, and which is why your hair stands the way they are. Either they are curly or wavy or straight, right? So suppose you want to straighten your hair, and we use this electric and heating technology here, right? All the material sciences come into play. So in the straightener, what it basically does is, when a hot flat iron is passed quickly and held tightly on the hair, the heat breaks down the keratin chains to move around and change their position, and they reinforce. So, for example, if you have a curly hair or a slightly wavy hair, the heat will rearrange the keratin to get rid of the wave or curl and give you a straight hair for a while. And then once you are having your grooming done, you move to your kitchen. And the kitchen is quite smart today. So I think except the user, probably everything around is smart. So today you have a smart kitchen where your app can tell you what's in the refrigerator and what can be a possible recipe that you can cook. And you have a whole set of smart kitchen gadgets. And then you step out of home, and today when I step into some of the cars, I really don't know if it's the normal passenger car. It's pretty much the dashboard resembles the cockpit of an aircraft, right? The kind of controls that you have, there is more electronics in the car today than the traditional mechanical engineering, right? So there's a lot of electronics there, and the dashboard is quite complex. I don't think anybody understands all of the indicators that are being flashed on. And you step into the office, and today the very conversation that we are having through a Zoom or WebEx or all of this, right? And the telepresence that we have, literally geography has become history today. The spaces have shrunk. And then you finish your work, and then probably you step out. There are those Alexa-linked microwaves where you can have some quick heat, you can have some food. And then in the evening when you step out, probably you have all these smart gadgets. You can book a taxi, and then you can inform home, and they can track you, where you are, right? And then you come back home, and all the while you're away from home, you can still monitor things, the vital things at your home, right? You can control your home refrigerator, the electricity, what's switched on, what's switched off, the air conditioning, right? So that it's all just perfect when you get in home. And while you're doing all of this, right, throughout the day, you have a smart Fitbit on your hand, which monitors the steps you have taken, your pulse rate, your heartbeat, and all of that, all of those vital parameters, right? And then when it's time to sleep, you can always call Alexa, Alexa, play my favorite songs. And that's the perfect lullaby, and then you sleep. Look at this all-pervasive technology that's around us, all made possible by engineering. So, what is engineering? Engineering is the process of designing human-made world. So, let's visualize this, right? As you can see from the graphic on the screen, there is science, there is technology, there is nature, and there is society. Science is all about the theory, the principles, the fundamentals, and all of that. And the technology consists of a lot of tools, right? The society has a lot of needs and problems. Nature has resources. Engineering, my friends, is at the center of this. Engineering is at the center of your society, nature, technology, and science. Engineering borrows the fundamentals from science, tools from the technology, resources from the nature, and then tries to address the needs of the society. Budding engineering students have designed, in response to the recent COVID situation, ventilator splits. They have 3D printed ventilator splits that could effectively double the usage of the limited ventilators that we have. They have designed drones, which is used to spray disinfectants in our own states, right? So it's happening around us, right? It's happening around us where engineers are designing, devising, creating new things, responding to the society's needs and problems. So my friends, engineering is not yet another course, right? It's all about how we design this human-made world. So now we have an overview of what engineering is all about, how it evolved as mankind evolved, right? So with that background, let's understand what's happening now. I see at least three things, or we need to approach this from three perspectives. One, what's the technological disruption that's happening? The second, the new ways of working that's coming in, right? And the third, how is engineering education equipping us to respond to this situation, right? So the first on technology disruption. And this is from Gartner's prediction, which you see on the screen. About 30% of IT organizations will extend the bring your own device policies to bring your own enhancement. New ways of working. The number of people with disabilities who will get employed will triple thanks to AI and emerging technologies. And this is interesting. By 2024, the World Health Organization will identify online shopping as an addictive disorder. And this is interesting because about 10-15 years back, we had de-addiction camps. It's not for alcohol. It's for digital de-addiction. De-addiction from WhatsApp, de-addiction from all your internet shopping and all of that. We had de-addiction therapies, de-addiction specialists, consultants, and even in Kerala we had a few years back in Rajgiri school this being launched, right? So I won't be surprised. So the technology in the day in the life of a modern man, I showed how engineering is all pervasive around us. But what's more worrying is how this technology is also getting inside you and tampering your DNA. And I would encourage you to look at this TED Talk by Scott Galloway, and he has also authored this book, The Four major companies, So today, for example, when you want to look for something, you don't seek a teacher, you don't go to the library. Where do you go? You go to Google. Google is the guru. And then, this has both plus and minus. And my own personal opinion, probably we have lost out on serendipity, accidental discoveries. In a library, when you go, probably you flip through some volumes, some books, before you get to what you are actually looking for. But today, Google, it doesn't even wait for you to type the complete question, right? So probably it's limiting our ability to think in a way, and we also start believing whatever it shows as the gospel truth. But I'm not getting into the specifics of that, but the point to be noted is, and this is from one of a senior executive of Google who went on to say, 1 in 6 questions that's being asked today in Google has never been asked before. That doesn't mean these questions were not there. These questions were there all along, but just that the faith today that Google will have an answer for everything has gone up. So Google has changed the way your brain thinks. It has tampered your brain. The second company of the 4 that Scott Galloway talks about is Facebook. Where do we show our emotions today? Facebook and Instagram and all of those, right? So there was a time when people used to write diaries, keep it secret, keep it under safe custody, and they would really get mad and wild if somebody gets to read those personal notes and the diary. Fast forward today, where are we pouring our emotions? I'm angry, I'm upset, I'm happy. It's all the emoticons and all the emotions that you pour out in Facebook and Instagram. And that's not that. We also get wild when people don't read what we are posting there. And precisely why we need all of these de-addiction camps now. And the third company he talks about is Amazon. More than 50% of the purchases in US is made online on Amazon. And that Amazon represents the gut, the consumption. And most of it, what we buy, probably we may never need. Right? So that's the third company. So no wonder by 2024, the prediction is World Health Organization will identify online shopping as an addictive disorder. And then the predictions go on. So probably individual activities will be tracked digitally by an Internet of Behavior. We know of Internet of Devices, it will be Internet of Behavior to influence benefit and service eligibility for 40% of people worldwide. Now, what this technology disruption mean is it opens up a series of challenges for engineers to solve. Advanced personalized learning. Today, in this lockdown mode across the world, people have figured out how Zoom and WebEx and all of these can be used to learn. The learning never stops during lockdown. So, how the instruction can be tailored to a student's individual needs, and given the diversity of individual preferences and the complexity of each human brain, developing teaching methods that optimize learning will require engineering solutions of the future. Making solar energy economical. Today, only 1% of the Earth's total energy is solar. So how do we make solar energy economical and viable? Enhancing virtual reality. Within many specialized fields from psychiatry to education, virtual reality is becoming a powerful new tool for training practitioners and treating patients. Advanced health informatics. As computers have become available for all aspects of human endeavors, there is now a consensus that a systematic approach to health informatics, the acquisition, management, and use of information in health, can greatly enhance the quality and efficiency of medical care. Securing cyberspace. Computer systems are involved in the management of almost all areas of our lives, from electronic communications and data systems to controlling traffic lights to routing airplanes. It's clear that we need to secure the cyberspace. And post-COVID, world offers many more such challenges for the engineers to solve. If this is what is happening around us on the technology disruption, let's look at the new ways of working that's evolving. I'm sure all of you would have heard about this gig economy. Gig workers are mostly independent contractors and freelancers. And the mantra of gig economy is no shift, no boss, and no limits. Take the case in our own country. The Indian Army employs 12.5 lakhs people, while the Indian Railways has about 12 lakh employees. So far, IT major TCS, with a staff strength of about 4.5 lakh, is the largest private sector employer. Food delivery platform Swiggy is planning to hire about 3 lakh employees, and it already has about 2.1 lakh. Zomato has about 2.3 lakh delivery workers, executives. Flipkart has about 1 lakh people engaged in performing deliveries. And then you have Uber, Ola, and so on. So the gig economy is real, right? And with Swiggy planning to do about 3 lakh more delivery executives into its workforce, probably it will surpass the TCS and become the third largest private sector employer, right? It's not just about blue collar. Even technology workers are turning on to do the gigs. The Top Coder, Kaggle, CodeChef, HackerEarth, HackerRank, Codeforces, CodeWar, CodeGym, Coding Game, Geek for Geeks. These are all platforms that are throwing up challenges from real industry. And these are great platforms, which today you can use to pick up your skills. Budding engineers should tap into these platforms. So we saw about the technology disruption, and then we saw about the new ways of working that's evolving. So how is engineering education and the engineering discipline tuning up to help us? So it has evolved from the traditional civil, mechanical, and electrical into newer branches. So today you have more than 40 branches of engineering today, but it's not those isolated branches that I am talking about. At work, it's becoming multidisciplinary. So we are evolving from multidisciplinary to interdisciplinary to transdisciplinary. So one of the branches would be Mechatronics, right? Mechatronics I see as an amalgamation of computer systems, control systems, electrical systems, and mechanical systems. So you have the digital circuits, digital controls, the actuators and sensors, the electromechanical systems. No wonder when you step into a car, it's more electronics today than the traditional mechanical and automobile engineering. So with all these technology disruptions, we would see artificial intelligence, Internet of Things, mobility, analytics, and cloud as new emerging engineering disciplines. In fact, artificial intelligence and data sciences is already a discipline that has been launched this year by Anna University and many other universities across. So if this is happening around us, this is the disruption that's happening around us, and this is the way engineering education is evolving, what should we be doing as budding engineers? So this is something based on the work that myself and my colleague Vaijayanti, we did some work with the students across the country, right? And this is also based on our experience of running this program, of bringing in fresh engineering grads from the various campuses and taking them through the training process in IBM, and in the last few years, probably more than 10,000 students would have passed through us. Right. So it's based on those. We did a research on what are those traits that make somebody a successful engineer, right? And then we also went to various campuses across the country, and then we could distill about 5 distinct traits and what we call as Shape It. So this is a book by the name Shape It as well that we have written with all those some 50 great stories about students like you on how they are acquiring these traits. Shape It. S for self-learning, H for hands-on, A for antennas up, P for problem solving, and E for entrepreneurial. So self-learning. Today, there's only so much that the engineering education and curriculum in the campus can provide you. And the half-life of knowledge in IT is 2.5 years. So in 2.5 years, 50% of what you know becomes obsolete. So how do you keep yourself current and relevant? Self-learning. Hands-on. It's not just about learning. Engineering is all about doing. So how do you get hands-on? How do you practice? How do you do things? And then having your antennas up. Remember the chronoducts? The next time you visit a salon, look at the electric shaver. Look at the flattener. Look at the engineering behind it. Stay inquisitive. Ask questions. Have your antennas up. Problem solving. And then the last one, entrepreneurship. Become a job creator, not a job seeker. Right? And IT stands for individual transformation for a whole set of soft skills. So if we cultivate and we nurture the shape it traits through the 4 years of our engineering education, and I'm sure we will be successful engineers. And the copies of this book is also there in the MITS library. If somebody needs a copy, please write to me and I'll be happy to send a few copies again. Right? So with that, let me conclude on what the National Academy of Sciences US talks about, the habits. So while the shape it talks about the 5 traits, what are those habits that we think an engineer should exhibit? Those are 6 habits. Creativity, optimism, persistence, systems thinking, conscientiousness, and collaboration. Creativity, it's all about engineers look for patterns across branches. Imagine new ways of thinking. Optimism, right? Engineers believe that things can always be improved. And that optimism is one of the key habits of an engineer. Persistence. Failure is expected, even embraced, as engineers work to optimize the solution to a particular challenge. Systems thinking. Our world is a system made of many other systems. Things are connected in remarkably complex ways. To solve problems and to truly improve conditions, engineers should recognize and consider how all those different systems are connected. Conscientiousness, right? Engineering has a significant ethical dimension. The technologies and methods that engineers develop can have a profound effect on people's lives. That kind of power demands a high level of responsibility to consider others and to consider the moral issues that may arise from the work. And the last but not the least is collaboration. Engineering successes are built through collaboration and communication. Teamwork is very, very essential. So with that, I would like to conclude this short lecture, if I can call, where we saw the evolution of engineering and how it evolved as mankind evolved. And then we saw what's happening around us now, the technology disruptions, the new ways of working, the gig economy, and how engineering education is evolving. And the last and the most important piece was, what do we do? What skills and habits do we need to exhibit? So we spoke about the shape it, the 5 habits, the self-learning, hands-on, antennas up, problem solving, and entrepreneurship, and the 6 habits. With these, I'm sure we will be successful engineers, and I would like to leave you with this short poem written by my friend that's flashed on the screen. Take your time to read. It's all about taking the first step. It's unknown for sure, but do not stop and take that step with a strong will. Thank you and all the best, and I'll be happy to connect with you on my LinkedIn, and my LinkedIn contact is given there on the screen. Wishing you all the best. Thank you.